Now say this numerical based on actually AC generator. Say here a rectangular coil of 200 turns of wire 15 into 40 centimeter square. It means we are given here area. Area is equal to 15 into 40 centimeter square, that is here 600 into 10 raised to power minus 4 meter square. Total number of turns in the coil is N is equal to 200. Now it makes 50 revolution per second, that is given here 2 pi omega is equal to 2 pi nu, that we know it here, and nu is given to here the 50. So we can write here in this case nu is equal to 50 revolutions per second. Now it is rotating about an axis in a plane parallel to its longer side and perpendicular to the magnetic field of intensity 0.08 Weber, that is the B is equal to 0.08 Weber per meter square. What are the instantaneous values of induced EMF when the plane of the coil makes an angle with the magnetic field of 0 degree, 90 degree and 60 degree? So now see here, we know instantaneous EMF E is equal to E naught sine, that is here omega t, we can write here sine omega t, or we can write here simply E naught sine theta. Now see, first we can calculate E naught. E naught is equal to NBA omega. So put all these values, that is 200 into 600 into 10 raised to power minus 4 into 0.08 into omega. So in place of omega we can write here 2 pi, so that is 2 into 22 by 7 into 50. When you solve this, you will be getting 301.7 volt. So that is actually the maximum EMF induced in this coil here. So now we have to calculate instantaneous EMF induced. So for instantaneous EMF, just we will be using this equation. E is equal to E naught sine omega t. Already we have got E is equal to 301.7 sine omega t, that means theta. So when the coil is making an angle of, plane of the coil is making an angle of 0 degree, then the theta is actually the angle between the area vector of the coil and magnetic field. So if the angle between the plane of the coil and magnetic field is 0, then the angle between the area vector and magnetic field is 90 degree. So you will be getting in the first case 301.7 into, that is sine 90, that is equal to only 301.7 volt. This is for the first case. For the second case, when the plane of the coil is making an angle of 90 degree with the magnetic field, then area vector will be making 0 degree, and we can write E is equal to 301.7 into sine 0, that will be here 0 volt. But when the plane of the coil making an angle of 60 degree with the magnetic field, then area vector will be making an angle of 30 degree, and you will be writing E is equal to 301.7 into sine 30, that is 301.7 into 1 by 2, that is here 150.85 volt. So that here you can calculate the EMF induced in the coil when the coil is rotated. So at the different angles EMF can be calculated.